So thanks very much for having me out. This is my first opportunity to come out to the M6 presentation, and I'm actually happy to be here. I want to spend a little bit of time talking about balancing mobile productivity and security. Now, my personal interest in these two things is that I've been involved in information security for about 20 years, and I've seen many of my customers during the time that I spent in consulting make some pretty crazy mistakes over the years. So I wanted to spend some time talking about the things that I've seen over the past probably 20, 25 years, and what I'm seeing as the emerging trends that are changing with respect to mobility and how that impacts the security of information. So let me jump into the content. I'll give you a quick introduction about myself, just so you know my background and how I ended up at VMware. I spent a little over 20 years in consulting, and my consulting career was mostly focused on RDSH or terminal services, virtual desktops, application virtualization, and enterprise mobility management. So a lot of the things that make up what VMware does in end-user computing. I joined VMware late September 2014, initially to lead desktop product strategy. And in January, I took over as the Chief Technology Officer for the EUC business unit. Now, I want to describe, from my point of view, end-user computing and business mobility, which are terms that get tossed around a lot. I want to be very clear in saying that mobility is not about mobile devices. I think too many times when people say the word mobility, they assume that you're talking about a smartphone, or that you're talking about a tablet, or you're talking about a cloud-based file share service like a Dropbox. But mobility is really about getting work done in a mobile state, regardless of the device or the data that you're interacting with. And at VMware, we spend a lot of time thinking about end-user computing and business mobility and how we can make it easier for people to get work done. Now, I promise I'm going to try to make this session not a commercial for VMware. I think I have 2 slides that are actually VMware slide content, and the rest are all just images that I pulled together. I want to spend a little bit of time, though, talking about the term digital workspace, or what VMware calls digital workspace. Digital workspace to us is something that kind of resonates or is synonymous with digital transformation. And digital transformation means a lot of things to different people. Digital transformation to some people means that you're converting from a paper-based processing to an electronic-based processing. But to me, digital workspace is all about how you change the way you do business to be able to service your customers more effectively at every single interaction of how you deal with that customer, how you interact with that customer. So it's all about the applications that you need to service that customer. Maybe it's a Salesforce, maybe it's Concur, maybe it's Workday, maybe it's data that you need to interact with the user. Having that accessible on every device, everywhere you go, is all about digital workspace. And there's 2 kind of key tenets that we use when we talk about digital workspace. We use the phrase consumer simple and enterprise secure. And the reason why we use these 2 terms is because this is kind of the balance between productivity and security that this entire talk is about. It's how do we enable people to be productive and to have quick access to information while still ensuring that the organization doesn't have the risk of losing their data. Consumer simplicity means a lot of different things, but to me, it's very simple. You don't have to train one of your employees how to use an iPhone or an Android phone or tablet. They pick it up, they find the app store, they download apps, and they're productive. This is something that takes a matter of minutes. Even children pick up smartphones and figure this out very quickly. Enterprise IT is the complete opposite of that. Enterprise IT is all about putting in a ticket, waiting 3 or 4 weeks to get service on something. It's not self-service. It's not end-user satisfaction. It's very complex. So we want to make sure we can enable our workers to be very, very productive in a simple way, but also balance that with the security that IT needs to safeguard the information that we're protecting. So to think through how this has changed over the years, I wanted to talk a little bit about an example of how IT security has operated for the last 40 years. This is a picture of the Oxburgh House in East England in Norfolk. And I picked this picture because it kind of represents exactly how security has existed in enterprise IT for the last 40 years. You basically had a perimeter, 4 walls, surrounded by a moat, and we only had one way to go in or out. Actually, this place technically doesn't have one way to go in or out, but pretend it does. The moat surrounds the whole place, and there's only one way in and out. Now, we can put all sorts of protections on the perimeter that safeguards our applications and data. And for the most part, this is what enterprise IT orgs have done for years. We've spent billions of dollars on firewalls, security products, and all of these have resulted in two major problems. One, the attackers have still found ways to succeed in getting through our perimeter defenses. Number two, it's made it increasingly difficult for our employees to get work done, particularly as they move outside the perimeter and operate in a mobile state. So as a result of that, we started building things like virtual private networks. How can we allow people who are operating outside the perimeter to get access to that data that's on the inside? Well, we'll simply just allow them to create a VPN connection into the data center and access all the data that they need. Now, the reason why I use the Trojan horse of Troy is because this is a very real-world example of what has happened with a lot of companies' virtual private networks. They create a VPN software, they give it to their users, that device that they're using is compromised, and it becomes an entry vehicle, sort of like putting down the drawbridge and allowing the attackers right in with the trusted users. So this has sort of been the problem that IT has faced. And as a result, our data center security model has kind of looked like this. It's sort of had this nice, soft, protected outer shell, but in the inside, it's all gooey. It's all gooey because we haven't been able to really focus on protecting the internal portion of the data center. We've been so worried about the outside perimeter. So when I think about this, the most important thing to remember about data center security model is that hackers are already inside your networks. Every single person in this room, hackers are already inside your data center. They've already compromised multiple users' desktops, and they're sitting there waiting to do something. Now, I don't mean to make everyone paranoid about this, but just keep in mind there's actually an opportunity here that we can actually make things better. In addition, as I talked about earlier, as people have moved outside the perimeter and moved into mobile work scenarios, they've actually needed that data, the soft GUI center, outside the perimeter. And this has created a challenge where the data itself is now existing on multiple different clouds, on multiple different devices. So it builds a challenge for us. And the traditional IT response to this was, well, if you want to have access to this data, you're going to use it on this device, in this location, under our control. And as users started trying to move out of that model, you try to store data in external third-party email systems, in various enterprise file sync and share solutions, and IT turns around and just starts hitting it with a hammer and trying to block everything. So this image, to me, sums up, in essence, why enterprise file sync and share consumer-based solutions exist. It describes, in essence, what IT has always tried to do. We don't want you to allow to do that. We're going to put a gate to block it. But the reality is that there aren't any mitigating controls that prevent somebody from simply moving to a different location and circumventing it a different way. They'll do exactly as you've seen in this case. They'll drive around the gate, and they'll store the data somewhere else. So it creates a big problem for IT. One other thing I want to mention about this as well is who's actually to blame when there is a security-related data leakage. Do you blame the end user? Sure, you can blame them. They should have known better. Do you blame the IT staff for blocking the ability to share this data with external sources or consume it the way that the user wants to consume the information? Do you blame the CISO, the Chief Information Security Officer? Do you blame the CIO? The reality is you should blame all of them because we're all part of having responsibility for this. I'm not going to go so far as to say that it's entirely on the company to provide easy ways to access mobile data. It's also on the end users to know which data should and shouldn't be shared externally. But ultimately, it's our collective responsibility. And the entire industry around governance, risk, and compliance is a shared responsibility by all of us. So I want to talk also about a couple of trends in data. And Maribel had talked quite a bit about increasing amounts of data and how people want to consume data. I want to touch on a couple of data points. These first two are from IBM. First of all, 90% of global data has been created in the last 2 years. That's actually staggering if you think about it. 90% of everything that's out there was built in the last 2 years. So every 2 years, 90% of the data that existed before is going to be recreated net new. So how do people find access to their data? How do we secure it? Where is it located? These are all legitimate concerns. 2.5 quintillion bytes of data is created daily. Again, another stat from IBM. These are kind of mind-numbing statistics. This is actually collected from a number of different sources. I could not find a single source for attribution, but the data point generally agrees that somewhere around 2017 or maybe 2018, consumers will store about 30 to 50% of their data in the cloud. Some people are already here. If you're using Google, Apple services for storage of your pictures and movies and music, you may already have more than 30 to 50% of your data in the cloud, but this trend is continuing. Likewise, the enterprise is following the same pattern. The average enterprise business consumer has data in 6 to 12 places. Where is this data located? It's in corporate shared drives, it's in their home drive, it's on intranet sites, SharePoint collaboration sites, Yammer, Socialcast, Slack, it's on instant messenger clients, it's on internet browser history, it's on files on their computer, it's on files on their phone, their tablet, it's in their home, it's everywhere. So what do we do about this data problem? Now, I don't mean to make this sound all doom and gloom. I painted a picture of hackers are in your network, data is spread everywhere, people are using data all over mobile devices. I don't mean to paint the picture that it's all doom and gloom. I do want to talk about a few things that I see that are happening in the productivity security balance that are changing how we think about protecting these assets. So first, and Maribel talked about this quite a bit, identity and context is very, very relevant to how we think about securing information. So when we think about identity, first of all, I don't believe that standalone identity providers or standalone EMM providers long-term will survive. And the reason why I don't think they'll survive, or at least it'll be more challenging to survive, is because everything is becoming important based on contextual access of data. And we have to be able to use information in multiple different places in order to determine whether or not a particular access to data should be allowed or disallowed. So let's paint an example of this. Let's say I have a person that works for my company that wants to take their own personal smartphone and access some confidential corporate data. Normally you'd say, I don't want to allow that. But in some cases, you might want to allow access to some key pieces of information that are non-confidential. So you have to have this blended spectrum of what's super confidential versus what's not confidential. You might want to take information about the resource the person's trying to access, the authentication or authorization of that user. In other words, what groups are they part of? What roles do they serve? How important is their role? What level of the company are they? Based on what level in the company they are, they might have access to more confidential data. In addition, you might want to take information about the device. Is the device a managed endpoint? Is it an unmanaged endpoint? Is it rooted from a security perspective? Is it up to date on patches? What time of day are they accessing this information? What pattern does that match of what they've accessed previously? Where are they accessing it from? Does this person normally operate 99% of the time in Chicago, Illinois, like I'm based in Chicago? Or are they constantly moving around? Does their IP surface somewhere in Asia or in the Middle East that they've never traveled to before? And there's a huge trend happening in analytics where you can take data about the person and use that data to formulate the probability of whether or not what they're trying to do is legitimate or not. So a lot of opportunity there to improve things. In addition, this is one of the VMware slides I want to touch on briefly. I want to make sure that we minimize the full device-level VPN tunnels in the future. It was very common a couple of years ago to just provide a device-level VPN to any kind of laptop, desktop, smartphone, or tablet. And there are companies that still today provide device-level VPNs. The problem with the device-level VPN is a compromised app running on that device can access that tunnel to get into your data center and infect resources. The good news is application-level VPNs are no longer a new thing. Despite a lot of companies not having rolled these out, it's been in iOS since version 7. It's been in Android since Lollipop. It's come in Windows 10. Windows 10 now has per-app VPN. And it's been in OS 10 since Mavericks. So there's a lot of opportunity to change the way in which applications on mobile devices access data center resources. In addition, you can combine that application-level VPN with a technology concept called microsegmentation. And microsegmentation can be implemented with VMware NSX, but there are also other software-defined networking products from like Cisco ACI, for example, Cloud Passage, Illumio, various other vendors that can provide similar software-defined networking functionality. When you combine the per-app VPN that wraps the mobile application, or in this case, could also be a desktop or a laptop application, tunnels it into the data center, and then terminates it onto a single IP address, you're very much limiting the scope of what damage can be done by that application. In addition, these same microsegmentation technologies can be applied to things like virtual desktops. Now, most people, when they think about mobile, they don't think about virtual desktops, but I'm here to tell you that there's actually a resurgence in virtual desktops that's happening in the industry right now. And the reason why that resurgence is happening is because you can do things in a virtual desktop that are simply not possible to be done on a physical desktop. Microsegmentation is a good use case example of that, where we can actually control what resources a physical device can talk to. So when I remote into a virtual desktop in the data center, that desktop cannot talk to any other desktop in my environment or any servers that I've not designated that your identity is allowed to talk to. Why this is so important is for large enterprises today that have tens of thousands of endpoints or hundreds of thousands of endpoints, if an attacker compromises one of those machines, do you want that person on a 40 gigabit Ethernet connection having super fast access to every other endpoint in your network and have time on their side to attack all those endpoints? Or would you rather control their access to, let's say, 6 hosts so that if an attacker does compromise a machine, it takes them that much longer to compromise the next host and the next host and the next host? The reality is today is when breaches are made in networks, it takes anywhere from weeks to months for the standard security team to find that that breach has occurred. A skilled attacker within a few weeks or a few months can easily spread from one host to the next, compromising the entire environment. So this microsegmentation technology combined with things like non-persistent discardable desktops makes virtual desktops a far more secure technology than any physical desktop or laptop can provide. East-West Traffic controlling in data centers is a very key developing technology trend, and VMware does have a play here with our NSX technology. I've got a couple of quotes here from Martin Casado, who was originally with Nicira, and we acquired him into VMware. So virtual machines in data centers do communicate with each other quite a bit. In fact, 80% of security spend in the data center is what's called North-South Traffic. The North-South Traffic is your typical firewall type products. So 80% of the spend is on there, yet 80% of data center traffic is occurring between virtual machines in the data center. What this means is we're missing a big opportunity to provide security within the data center. And it's not just technologies like NSX or other SDN, software-defined networking technologies, that can improve things. There are other things that we're doing at VMware to improve data center security as well. We have an emerging technology called the Goldilocks zone that's been invented by our network security business unit that'll be coming out in a bit. And what the Goldilocks zone does is allow you to provide secure attestation of a virtual machine to basically be able to compare it to what you think it's supposed to be doing. So let's say this device is a web server. The behavioral pattern of a web server is to receive a bunch of inbound connections and serve content. If that device starts doing something that isn't normal of a web server, you can sample the data securely through the virtual machine technology, and you can say, hey, this device is not behaving how it's supposed to be. Let's quarantine it off on the network and go examine it right away, as opposed to letting it sit for weeks or months. Two-factor authentication. I've got a couple of links here that you can jump into if you want to see more information on this. I did about a 75-minute presentation on multi-factor and two-factor authentication at a conference about 2 years ago, and that video recording is online at the bit.ly link there. The passwords are dead. What I mean by this is traditional passwords are not good enough anymore. They're not good enough for a number of different reasons, but most importantly, the average user has about 26 different passwords today, and it's a rising number. It keeps going up. Out of those 26 passwords, they only have about 5 of them that are constantly reused. So the problem with the reused password is once a single password's compromised, it compromises all of the sites that that password's been used on. There's a website there for consumers called turnon2fa.com. That's a really good resource just for your own personal protection to learn how to two-factor enable things like iCloud, Twitter, Facebook, all the common consumer sites that you use. But two-factor authentication is a real thing today, and there's no reason why you shouldn't be enabling it for all of your remote access technologies. And by the way, two-factor authentication does not mean it has to be complicated. There are ways of combining biometrics and push notifications to mobile devices and Bluetooth Low Energy between devices to make it so it's a simple technology to use. Internet separation is another very, very important trend that's occurring. I'm seeing this happen a lot both in government and military organizations, but also in certain markets. Israel, there's a huge demand for this. Japan and Korea both have a huge demand for this. What internet separation is really all about is the two most common ways for your desktop or mobile device to be compromised is through the internet browser followed by the email client. And so what a lot of organizations are doing is saying, how do we protect our internet browsing and how do we protect our email client? One way to do that is actually to move it off of the system that you're actually running it on. So within desktop and laptop scenarios, we often put this into a DMZ in the company, or we put it into a hosted cloud offering. And when you want to browse the internet, you actually will use a disposable browser in the internet that if it's compromised, it doesn't matter because it doesn't affect you. Now, that's great for desktop, laptop use cases, but what about mobile devices? Most web browsers on mobile devices are based on something named WebKit. WebKit has numerous vulnerabilities. So today, most of that rendering actually occurs on the browser on your mobile device. In the future, as 5th generation mobile networks come about, you will have gigabit connectivity with about 1 millisecond of latency. At those network operating parameters, you will not be able to discern a website that is rendered locally versus one that's rendered remotely. So it's a good opportunity for us to rethink where should internet sites really be displayed? Should they be running on my device or should they be running somewhere else? The last thing I want to talk about is shadow IT. So shadow IT is an interesting topic, and I want to cover really quickly why this is a big problem. Shadow IT is kind of what led to the IT people putting the hammer down and turning everything off because people started moving data around and using third-party email services and third-party EFSS platforms. But shadow IT effectively just means going out and signing up with your credit card to some cloud-based service because it's faster for you to provision that than it is to ask IT for an application or service. So shadow IT is driven by the end users, but it quickly becomes the company's problem. It becomes all of our problem. Why? Because our data is in many places that we don't know how well those entities secure that data. To give you some context on this, Cisco had said that about 41% of public cloud in 2013 was SaaS-based services, software as a service offerings. And that number is going to go up to over 60% by 2018. So SaaS is quickly eating IaaS and PaaS in terms of market share because it's so easy to consume, it's so easy to use. The problem is all this data is out there, and in some cases it's being held in very insecure ways. Now, there's a technology category of companies out there named Casby. It's actually a Gartner term, but it's becoming kind of the standard industry term for it. Casby is Cloud Access Security Broker. And this is not a VMware technology. We partner with some Casbys, but what a Casby basically lets you do is take all of your logs from your firewalls or your proxy devices, forward it onto this Casby solution that basically tells you all the resources that your end users are consuming. Now, to give you some context on this, when I talk to CIOs and CTOs about SaaS, they say, oh yeah, we're using some SaaS. We have about 5 or 10, maybe 15 SaaS applications we use. Now, I'll quote some data from Netscope in a cloud report they released in 2015. The average number of SaaS applications in use by a North America enterprise is 798. The average number of SaaS applications in use by an EMEA enterprise is a little over 500. Why the disparity in what we think people are using and what they're using? Because shadow IT has meant users can just do what they want. So shadow IT is a big problem that we all have to become more conscious of and try to find ways to actually secure that data. And Casby is certainly a good step in the right direction. So with that, I'm out of time. I'm certainly happy to take questions after the fact, but thank you very much for your attention.